Okay, so this problem is one that probably initially leaves you scratching your head. D theta over 1 minus sine theta. What the heck do we do here? What do we do with this problem? D theta over 1 minus sine theta. I don't know. Right? I can't let u be sine or even 1 minus sine because I don't have a cosine up there to account for that. Well, this is one where we actually go back to a series of trig identity techniques that we actually use. And so the key is actually going to be to multiply by 1. This is actually another multiply by 1 type integral. Kind of like we did with the complex fraction earlier with the e to the x1. Kind of like we did here with the e to the x1 when we had the complex fraction. We multiplied by 1. But the question is, what do we multiply by? How do we multiply by 1? So that we can transform this into something we can actually work out. Well, the key idea is this. We recall our trig identity, the big one, cosine squared theta plus sine squared theta is equal to 1. And what that means is that if you solve for cosine squared, you'd have cosine squared theta is equal to 1 minus sine squared theta. But 1 minus sine squared theta can be factored as a difference of squares. And likewise, if you had solved that equation for sine squared, you'd say sine squared is 1 minus cosine squared. And what you would get there is you could factor that as a difference of squares. 1 plus cosine times 1 minus cosine. So anytime we are dealing with an expression where you have something like a 1 plus sine, a 1 plus cosine, a 1 minus sine, or a 1 minus cosine, then we always keep in the back of our head that we can use its partner to transform it into a difference of squares. And in trig, what that did allow us to do with our trig identities was we actually translate from a identity involving sine or cosine over to one that involves the other function. And so that's what we're going to do here, is we're actually going to multiply both top and bottom, but specifically the bottom to make it a difference of squares. We're going to multiply the bottom to make it a difference of squares. Okay, so that's what we're going to do. So in this case, our d theta over 1 minus sine theta, we're going to multiply both top and bottom by 1 plus sine theta. So we're going to use this common idea to transform the way this looks. So when we do that, we will get the integral of 1 plus sine theta on top over, well, we chose that to make it a difference of squares, 1 minus sine squared theta and d theta. And of course, the reason we did that is so that we can convert this into a cosine. So on the top, we're still going to have 1 plus sine theta. On the bottom, 1 minus sine squared becomes quite simply cosine squared theta d theta. Now, how does this help us? Well, for one thing, now we have a single denominator. And so having a single denominator, we're able to break this up into two separate fractions. On the one hand, we'll have 1 over cosine squared. But 1 over cosine squared, that is just secant squared. And we know how to do the integral of secant squared. On the other hand, we'll have sine theta over cosine squared, which we're actually going to be able to get by with a substitution. So let's continue on that vein. This will be now breaking it up, the integral of 1 over cosine squared plus sine theta over cosine squared theta d theta. And then we set about trying to work that out. So first of all, 1 over cosine squared is again just the integral of secant squared d theta. So that one's pretty straightforward. That part is just the tangent. Right? Secant squared is just the integral of secant squared. Secant squared is the derivative of tangent. So the integral of secant squared is just the tangent. Right? Plus, then we have our second part. And there's actually a couple ways to do that. On the one hand, if you recognize that you could rewrite this as sine over cosine times 1 over cosine, or if you spot that, idea here, then you know you could rewrite it as tangent secant, and you know that the tangent secant, that's the derivative of secant. So the answer would be secant, if you recognize that. That might not be something you recognize, and it'll only work for this unique one. So here instead, what I'm going to do for this one is I'm going to do a substitution step and let u be the cosine for that second integral. So here I have integral of sine theta over cosine squared theta d theta. What I'm going to do here is I'm going to let u be cosine. So du would be the derivative of cosine, which would be negative sine theta d theta. So I look at what I have, and I say to myself, well, I'm almost there. I have the sine theta go with the d theta. All right. I'm just missing the minus sign. Well, the minus sign is easy enough to fix. We'll just put a negative out front. Here we have 1 over cosine squared. And now fix the minus sign by putting it inside as well. So now we have 1 over u squared du. Okay, 1 over u squared du. So we can carry the substitution through, minus the integral 1 over u squared du, which is minus the integral u to the negative second du. And then we use the power rule, add 1 to the exponent, which will make it negative 1, and then divide by negative 1. So when you divide by negative 1, that'll cancel with the other negative. So we just get u to the minus 1 plus a constant, or putting back in for cosine, 1 over cosine theta plus a constant. And then we put those two pieces together. Tangent theta plus secant theta plus a constant. And now we have our result. Okay, so this one is a little tricky because initially we have to recognize this need to multiply by 1. This is something you will run into, and you will see if you have that stuff involved. Now, if this had been in the numerator, I wouldn't even bother with any of this stuff. All right, I wouldn't have done any of this stuff. I'd have just, worked with the top and gotten through it that way. Okay, but since it's in the bottom here, I use this idea of multiplying by 1, and in this case, multiplying to make it a difference of squares, so I can eventually convert the bottom into a single term. Cosine squared, which in this case pairs up nicely with the two pieces. Okay, so we did have a couple of different parts involved here. Right, the one was pretty straightforward. The other we had to use a U substitution on to work that out. Okay, but in the end, we get the answer that this thing, 1 over 1 minus sine theta, is actually the derivative of tangent theta plus secant theta plus a constant.